Welcome to the Makino showroom in Auburn Hills, Michigan. My name is Brian Coward. I'm the EDM product line manager for Makino. With me today is Dave Robinson, EDM applications team leader. And today we're going to be talking about Syncer EDM programming. This will be part one in a series of two presentations that we're going to do concerning Syncer EDM programming. And today what we're going to go over is on our Hyper-i Control, Syncer EDM Control. We're going to go over project programming. Project programming is the programming system on board on the Hyper-i Control. We're going to go over the most commonly used type of programs that we will create in project. We're going to go over post machining, open side machining, and solid machining. We'll also go over technology selection, how you select your technology in project, why you select certain technologies based on certain applications that you're going to be using, and orbit selection as well. There's several different orbit patterns that we can select inside of project. Dave's going to go over those different patterns, why we use them, when we use them, what the benefits are of different types of orbit patterns. And then also we're going to go over some unique Makino machining features. These are some of the technologies that are specific to Makino and the Makino control, and we're going to go over those and explain what they do, what the benefits are, and when you should use them. And then lastly, Dave will go over some of the M codes that we use on the Makino control, what they do, again, what it activates and deactivates based on the different types of M codes that we use. And then after the presentation, we're going to have a question and answer session with Dave and me, and we'll answer any questions that you have. But now let's go out to the machine where Dave's going to give us a demonstration on the project programming.
Thanks, Brian. So today we're going to work on project programming. So I'm going to give you a demo of the basic project programming today, go through some of the screens and how to complete a program. So now we're going to go ahead and get started on doing a project program. So Project is the onboard programming software that's in the Syncers. So we're going to go ahead and start a new project. So first thing I'm going to do is create a new project, give it a project name. So once that comes up, we're going to go into the Edit Technology screen, and this is the basics of the project programming. So we're going to work on three different techniques today. We're going to do a post machine. Post machine is basically something that's been milled out, sent to heat treat, and then we're going to go out and pick out corners or sharpen up detail with post machine. Open sided, so anything that has the benefit of gravity to remove the debris where the electrode breaks out of the cavity wall is open sided. And then solid, so solid electrode into solid material. So I'm going to go ahead and do a program for solid. Next, I'm going to select the workpiece material combination. So what type of electrode, and then what type of workpiece material as well. So we're going to do steel, select steel, graphite to steel, go in and select our spark area. So spark area is the frontal contact area of the electrode. That's in ranges, so we have ranges anywhere from 40 thou up to 12 inches square, so very small to very large. So I'm going to do a 1-inch square graphite electrode. Next, select the cavity depth, how deep that we're going to burn. Again, in ranges anywhere from 80 thou to up to 2 inches deep. In this case, we're going to go 250 thou deep, or a 1/4 inch. And then lastly, I need to pick my surface finish, or on the machine, what we call roughness. So here we can have scales anywhere in micromillimeter RZ, micromillimeter RA, or VDI. In this case, I have the machine set up for micromillimeter RZ, and we're going to burn to a 5 micromillimeter RZ surface finish. Once I've selected the roughness, I can set our machining priority slider bar. So 3 settings on the slider bar. Either we lean our program towards quality, towards standard, basically middle of the road settings, or do we want to go fast and we set it to speed. In this case, we're going to set it as standard. Once I've done that, Then we need to set up the orbit settings for the machine. So I'm going to go to the orbit set tab. And then when we get into orbit set, we're either going to have in the basic side 2D circle, 2D square, or spherical shape, which is probably the most common in mold work. So in this case, we're going to do spherical. Then we're going to select precision level. So what precision level or what level of accuracy for the orbit. In this case, we have high or standard. I'm going to go ahead and select precision level of high, and then put in our electrode reductions, undersize or overburn, depending on what you call it. So in this case, we call it reduction. I'm going to select a 10 thou reduction for all 3 electrodes. Once I've selected the reduction, I can then go to the option set tab. These are going to be our proprietary Makino technologies, so our machining options. In this case, we have Super Spark, AF control or arc-free control, HS rib machining, and then also output of off adjust setting. So I'm going to go ahead and select what I need there. And then lastly, our M codes, or what we call M functions. We have polarity reverse, our through spindle flushing, rotation, so C-axis rotation, our tank up, so we can program the programmable drop tank to a setting height. And then if we need the work tank down, we can check the box for tank down after machining. So in this case, I'm going to set up the tank height for 10 inches. Also have the work tank come down after machining. And then click OK. So at this point, now it gives me a small snip of what I selected in the technology pick. Lastly, I need to set up my start point and my end point. So we're going to set up our work coordinate, G55. We're going to burn on center, start 200 above, and set our C at 0. And then program in a machining depth. So again, we picked a 1/4 inch previously. So I've selected 1/4 inch for our depth. And then lastly, tell it how many electrodes and of each and what ATC number, automatic tool position number, we want to assign. So I'm going to pick a rougher and a finisher, assign my 2 ATC pots, click save. At that point, the program's done. It wants to know if I need any sequencing, which I don't. I save again, and then put in my program number. So I've labeled the program test, click OK, and at this point, a basic project program is done. So literally only about a minute to program a project program in the sinker. So that was the basics of project programming. So we're going to go ahead and head back into the EC Center where Brian Coward's ready to answer some questions. So down in the lower right-hand corner, the chat function, Brian or myself can answer any questions on project programming or any of the questions you have on any of the Makino sinker product. Thank you.
Thanks, Dave. Now, Dave and I are available for any questions that you have concerning sinker EDM programming.
All right. Thanks, Dave. So as we said, we're available for any questions that you have. Again, there's a chat function there. You can see in the screen or the Q&A, either place. If you want to put in a question, type in a question for us, and we will try to answer it as best as we can.
So first question that's in there. So what is Super Spark? So when I went through the Makino technology, the proprietary technology to the Makino control, I checked a box called Super Spark. So if you notice next to Super Spark, there was a draft angle box as well. So what Super Spark is a technology that takes advantage of the draft that we normally put on electrodes anyway in the mold work side. So generally for plastic dipole, it needs a draft. So the electrodes then are drafted. They can be drafted anywhere as low as a quarter degree draft up to sometimes as high as 5 degrees of draft. So we take advantage of that draft that we're putting on the electrode for the pull. And because you're going in small and it's getting larger with that draft as it goes up, we then use that draft angle to remove some of that extra stock at the top because it's larger than the bottom. So we do that by basically going more aggressive on the processing. So we basically cheat back processes to be more aggressive and get a higher removal rate. So that higher removal rate, because of the draft angle, allows that cycle time to be cut sometimes up as high as 30%. So really good feature, just taking advantage of that draft angle. So when we put that draft angle in, when we check the Super Spark box, it's going to be the draft angle of the smallest draft angle side. So if it is 0, we don't put anything in. It will make us a slight calculation adjustment and jump back one process if there's no draft angle and the depth is a certain depth, generally about 600 thou deep. If not, if it's higher than that, then of course it's going to use it. And then if there's draft angle, it trades out that calculation, makes all of the processing, it changes the settings, jumps back processes. And it's nothing the operator has to control. It makes all that calculation where there's math adjustments and decisions in the background. So the only thing you'll see on the control is the Super Spark indicator light up in the upper left-hand control.
All right. Thanks, Dave. David has a question. How do you program any work setting functions using a probe?
So the probing comes from basically a probing system setup screens. So the setup features are separate from the programming itself, at least in the project side. So our conversational programming system called Model Plan, so it's independent project. Those you also program in the pickups as well as burn settings. And then on the setup screen, it's the same graphical style system to do any of your pickups. So we basically substitute a probe for the electrode, be it a touch probe or a physical contact probe. So many different ways of doing probing in the sinker. So it really depends on if you have a touch probe or if you have the trigger style, like a Renishaw style probe.
Okay. All right. Very good. Kenneth has a question. What are the advantages or disadvantages of using reverse polarity?
Good. Actually, good question. So reverse polarity, normally in standard sinker setup, electrode is in the spindle. So that would be a positive polarity burn. So basically the power is going to the electrode side. The workpiece is the negative or ground side. So when we flip the polarity around, it's going to burn much faster. Disadvantage in negative polarity is wear. So our electrode wear goes up significantly. Anytime we burn hard materials, let's say tungsten carbide, the technology's already set up. It's a negative polarity burn. So the electrode's going to wear at about 20%. That's going to make us burn a lot faster. Carbide's a more difficult material to burn. So we generally, all of our technology is set up in negative polarity. So that automatically happens in the background. Also, a negative polarity setup would be gates. So our gates that bring in plastic, generally they're pencil pointed, very small area, good area to have problems with because it's just comes to a pencil point. So it's a single point of contact, a little tougher to burn. We burn that negative polarity. The gate electrode's really easy to produce. So we burn that in negative polarity, get all that stock out of the way in that difficult burn. Then we go back in with positive polarity and the electrodes after second, third, fourth, depending on how tight we're going to hold that gate, and then go back in with positive polarity. So negative polarity has some good features, but on the other side of it, there's some negatives on the electrode wear side. So knowing when you want to use negative is definitely a good thing in the sinker, but a good technique to use in certain areas of process.
Okay, good. So I had one question also here on the machining page with the slider bar. So you've got, the speed, the standard, and quality.
Yep.
What does that slider bar change in terms of your program when you move it one way or the other?
So, yeah, like Brian said, 3 different settings. So quality, when we're in quality, you lean towards quality. Really what we're looking for in quality is truly surface finish. So what it does is it adjusts the settings to be less aggressive as far as the start process. And then also we have what we call bottom and side remain. So all of the technology is based off of those bottom and side remain numbers. That's the step over amount or the offsets, similar to like in milling or wired EDM, that's basically just our offset. So the amount of stock that's left in between each process. So what it does is it adjusts those by a percentage. So as we slide that slider bar towards quality, each step then adjusts that bottom remain stock and side remain stock. So it adds more stock to the finish side and takes less out on the roughing side. And that's just to ensure that we get the best finish possible, that we're taking out a little less on the roughing side and more on the finish side to ensure that high quality finish. On the opposite side of that is speed. So it does just the opposite, much more aggressive as far as its start process. And then it takes that bottom and side remain stock and takes it the opposite way. It takes out more with the rough and then less stock to finish. So generally between 10 and 20% less stock on the finish side. So we get speed with that, but there's also a risk that we may not hit that target surface finish. So we had talked about the drop downs and the roughness area, basically what surface finish we want. So if we programmed, let's say, a 5R max finish, I may only get a 6R max finish because I've taken some of that stock away, and that EDM crater that's created, it may not clean up. So always risk with sliding towards the speed side, but understanding, what that's going to do and how it adjusts the surface finish is key.
All right. Very good. Skip has a question here. He said he saw a template folder, and can you use that to copy programs and adjust it per job?
So part 2, we're really going to get into the template side a little bit more, but just a good basic explanation. So the templates, we go through multiple pages to set up the technology, electrode material combination, spark area, the reduction, orbit pattern, those types of things. So if you do work that's common every day, we have the same finish. It's solid or open-sided. So we can skip a lot of those steps that if I do work that's the same, I can set up a template in the template maintenance side, create a template. That way, when I come in, I click that template, it fills out all my boxes. Then I jump into the work coordinate side and then my depth. So I can cut 30 seconds out of my programming. So there are 20 template places available to create templates and throw those into. So, and that's something we'll talk about in part 2 as well next month.
All right, very good. And then Cody has a question. Is it possible to burn a helical profile?
Yeah, actually, very simple as well. So up in the technology section, edit technology, there is a section for helical, for gear machining. So really all gear machining is it's more of the movement of the machine. So what we call ZC movement, where we synchronize the Z and the C. So we'll have X amount of revolutions in the C to match the Z depth. So the jump motion also is that same ZC reverse path. So nothing the operator has to do. Really, all we're doing is putting how many C-axis rotations or how many degrees based off of X amount of Z depth. So very simple. And then if it needs any kind of orbit with that setup as well. So very good section on the helical machining side. If you take a look at that, and any guys that do the helical gear machining, they'll really truly understand the setup pages, and if it's lead entry or module entry, how that setup is from the data they get off of a print. So it's really designed very well. for the guys that do helical gear machining, and they'd really understand at high level.
All right, very good. All right, that looks like all the questions we have right. Oh, we got another one here.
Okay.
Here we go. So Juan wants to know best on-the-fly changes during roughing for small counter bore burns and multiple small features on the same electrode.
Yes. So on the fly, really using the condition page or the jump settings, that's probably the areas you're going to work on. The top row in the Hyper-i sinker, basically those are the settings or the elements of the E code that you're going to want to change. So, and then also the servo adjust. So we can adjust on and off time. We can also adjust the IP or IPL depending on which generator you have, the digital generator or the analog generator. IP is just your working amperage. So do we want to put more amperage or less amperage to the burn? Adaptive control, though, really all of the Makino sinkers have adaptive control. So there are what's going to actually make those adjustments on the fly better generally than the operator can, because it monitors the spark constantly and it's adjusting. So its first line of defense is to add off time to stabilize that. So once it adds off time, stabilizes, then it starts to take that on time and put it back in. And then also that off time adjustment back where it belongs. So it's adjusting that. Any of the guys that now have the version C EDAF sinker, as well as some of the new EDNC machines, we've also added a new adaptive control. It's called AISF, or Adaptive Spark Function. It takes our adaptive control, which was called P-Pulse from the previous version of machines, and now taking that to the next level. Instead of adding off time right off the get-go, now we adjust the jump to jump more frequently to try to get that debris out of the way and not slow down the process. So anytime we add off time, it's going to add wear to the electrode and then also add cycle time. So we're trying not to do that. So that's where the adaptive spark function comes in, or AISF, to change the jump first. And then if it still has issues, then we go after the off time to adjust that on the fly.
Okay. So if you had an electrode like Juan's talking about with multiple small features on the trode, the good thing to do would be to measure the frontal area of all of the features that are going to burn. And then that would be the selection you would make during programming, and then allow the adaptive control to adjust as needed.
Yeah, correct. So yeah, that way, as it, if they're not hitting at the same level when they start, the adaptive control then will either jump more or add some of that off time to adjust, because we're starting on a small area. And then as we go deeper, we start to pick up area, and then it gets more of what you technically programmed to. So then the machine is much more efficient. So the adaptive control is really the key in this case. That, if we go in on a pencil point and then we go up to a large area, it lets the machine make that adjustment in the background and adjust on the fly, and then go back to your program settings to run efficiently based off of the area you picked.
All right, very good. And then Michael has a question here. When does machining direction matter? Which I don't understand that myself. Maybe you understand that, Dave, what he's talking about.
Yeah, I'm probably talking about machining depth. So on the basic one, we just talked about a Z depth, Z axis burn. So the machine is capable of Z positive, Z negative, so it will burn in the up direction. But for any side burns or vector burns, so the next selection over for machining direction. So basically, we're giving the machine an endpoint based off of its start point. So just to do a side burn, we just select either X positive or X negative direction to go in X, and then what the distance of that burn is, be it incremental or absolute. So very simple to do side burns or vector burns, is we're just going to put in an endpoint, and then it's going to do a burn basically from point to point. It's really a very simple system. So we give it a start point, give it an end point. That's the vector or the directionality of the burn. And then any orbit patterns, be it complex or simple, will orbit around that vector. So it's not anything the operator has to do. It's actually a very simple process, and much simpler than it used to be, that you'd have to do calculations and stuff on certain stuff when you did vector or sideburn. So this has taken a lot of that problem out of it.
All right, very good. Well, it doesn't look like we have any more questions here right now. So I would want to thank everyone for taking time today to talk about Synchro EDM programming. We will be having part 2 next month. So please join us for that. And Dave's going to go into a little more depth of things like the templates, how they work, how they function, and some of the orbit patterns as well, to give you a little more information on programming Synchro EDM. So thank you, everyone, and hopefully we'll see you all next month.